Hi, everybody. I'm a software engineer at Agoric and working mostly on the Chainlink integration recently. But it leads to an interesting question, which is once you've created a dApp and have it all tested, how are you actually going to get it onto the testnet? So as before, the questions are taken on YouTube Live and Discord. Please ask questions after this presentation. We're all present on Discord and we'll get to you as soon as we can. The agenda for today is we'll talk a bit about dApp architecture. We'll actually deploy a dApp to the Hack the Orb testnet. And we'll talk about the next steps, where to go to improve your dApp and what we really want to do in the future. So dApps are made up of AgSolos, browsers, and chains. Oh my. Basically, AgSolos are single clients that run off the blockchain. Browsers connect these AgSolos with each other over HTTP requests, and the chain itself is using also an Agoric platform, but it's running in a replicated state with different validators. So the wallet is a trusted app on the user's own AgSolo, but dApps are basically web UIs that have their own agendas. And the Dapp API servers are a Dapp's public AgSolo. So this is confusing, so let's look at a diagram. Basically here we have, in the yellow box, we have the user's private host, their own computer. And in the blue box, we have a Dapp public host, which is a server somewhere on the internet. And in the red box, we have the Agoric chain. So the user's private host has an AgSolo, which is the Agoric VM. But it's not running the chain software. It's just connecting to the chain. That's where AgChain Cosmos is running on each of these validators, these multiple validators. And on the chain, we have a deterministic replicated environment where we have Zoe and contracts and other kinds of services provided by the chain. So from the AgSolo locally, this is how most of you Dapp developers have been working, is you run Agoric start, and it starts up an AgSolo for you and a simulated chain. The AgSolo you can interact with the wallet UI, which talks to the wallet backend. But when you build up a Dapp, you're actually using a different UI, one that's provided by the Dapp, to talk to your wallet. This is a secure connection. It's specific to the Dapp itself and not the same control that you give with your own wallet UI. So the Dapp UI would be served from the Dapp public host, and the Dapp UI talks to the API on the public host, which uses its own AgSolo to provide access to on-chain contracts that only the Dapp public host can access. So the Dapp UI is basically in between your own AgSolo and the Dapp's AgSolo, and negotiating between them to create offers and to actually enact them using the contracts on the chain. As an aside, the Dapp public host has its own wallet UI for its own wallet that's running on its AgSolo. So this is how the Dapp author could control, say, draining the tokens from the contract, which only it can do, or sending tokens to the contract if it needs to. So the Dapp, or the wallet UI, basically runs on an AgSolo, and it allows you to enable or disable connections from dApps, and approve or decline proposals, and manage pet names. So pet names are, I'll show you a little bit about that. We talked about it earlier in how to use the wallet. But the untrusted web UIs, they can be anywhere, and they usually want your money. Sometimes they just want to give you something, but usually they're providing some service where they get paid. And you use your own wallet to control what access they have and to manage the proposals. Finally, the Dapp API server is a publicly accessible AgSolo that provides HTTP or WebSocket services. It's the backend for the Dapp UI frontend. And it usually has privileged access to the deploy contract. Just like any other backend with privileged access to a database, it provides only the operations that it allows publicly. So it limits the authority that the Dapp has, the Dapp UI has, by giving it only what it needs and not just whatever it wants to request. Okay, let's deploy a Dapp. So because this is working on the actual testnet, I recorded this in advance, and basically I just want to show you the steps that we go through. We'll talk later about latency and how we can improve it. So this is the starting situation where we just have some terminals open to the Dapp that we're actually running in. And let's see how it goes. So we want to first compile the Ag Cosmos helper backend. So this is part of the Agoric SDK. Currently, the client for the testnet is partially written in Golang, so we need to run a make command in order to compile it. So I'm just going to fast forward through here. So that was how the compilation goes. Now we should be able to run. Yes.
And sorry. Michael, if possible, do you mind zooming in? I'm not sure if you're going to be able to do it with your Windows that way.
Unfortunately, I can't with the video, okay. But I will later.
All right, no problem.
So we can run the helper and just request the version to make sure it's installed correctly. And it comes back saying we're running Agoric Cosmos helper version 0.23, which is exactly the right version. Next thing we want to do is start the testnet. So we'll start the testnet client on port 8000, and we're running against the hack the orb testnet. So this is the special command in order to do that. Then we start it off, and basically it gets going, just like running Agoric start without any arguments, except this time it gets some network config and actually sets the chain up. So this is using the actual hack the orb testnet running on the internet. It starts complaining, saying that we don't know where that address is. So we have to go tap the faucet on Discord. This is when the faucet channel on the community team. Basically, you just run the command that it told you to run. And this is how it works. I'll fast forward this as well because it comes back with a little thinking icon. That means it needs manual approval. So we'll just go through the actual approval process, and then it eventually gives back a check mark. So that check mark means that our actual Agoric solo has been provisioned. And now it starts to give chain messages back, saying that it could not find the peer mailbox. That's just syncing up with the chain. But now it's actually sending transactions to the Agoric testnet. I'm going to fast forward through here. Well, actually, first, I'll just show you how we deploy the contract to the chain. So because the Ag Solo is connected to the chain, we just run the same deploy steps that we would have done with our Dapp otherwise. This will take a while because it first has to synchronize with the wallet, and the wallet has to synchronize with the chain. So I'll just fast forward past this so that we can get to the exciting part. So each of these O's actually takes place once every second. So this is zipping past a whole bunch of messages exchanged with the chain. Still a bit faster than waiting for an Ethereum block to finalize. So eventually we run and install the contract, and we deploy the API server. And we're just getting the board IDs back as the regular deployment does. And there they come. So now it's been deployed. And let's see what happens next. So we're going to open up, start up the UI for the Dapp faucet, and also run the Agoric open command to get a wallet. Okay, so that's the end of the video. I now have the Agoric wallet live, and this is exactly where the Dapp all comes together. So many of you have seen this already with the Agoric faucet, or the fungible faucet. But what I'll do now is I'll go to the local, the fungible token faucet, and it tells me that I need to approve it. So this is the usual step with fungible faucet. I like calling it Kate's faucet because she built it. And then I'll just enable that. This should add some new tokens to my wallet. It takes a little while because we're going through the chain. But if I hit the mint command, then I'll come back to here, and we'll see that the the Dapp is creating transactions back and forth to our Ag Solo. And we're just going to wait for the actual payment to go through. Let's just check the debug messages, make sure that it went. Very bottom. Okay, so we did. Yeah, we are sending back and forth messages still. So we're adding an offer. So now we have the Kate's Faucet token here. The offer should be coming through pretty soon. We'll just watch it from the Dapp. We have the proposal. As I said, we'll be talking about latency later. I'm just waiting for this proposal to go through. Okay, the Zoe invitation has gone through. So this is the Dapp API server sending an invitation to Zoe, to our contract. And then pretty soon this will be cached in for the actual invite. Just waiting for it to happen. Not sure why it's not going through. Let me try another one. I might have hit it too early for it to properly register. Okay. So here should come another invite. So there's the invite for Zoe. There's the invite appearing in our wallet. It gets transferred to our invite purse. Should show up here as the second invite. Yeah. And then it should result in an offer. There's the offer. Okay, so this is the proposed offer from Kate's Faucet. We want 1,000 of Kate's Faucet tokens, and we want to deposit it into our purse. So we'll just accept that offer. We'll see if we can cancel it for a little bit of time before it actually gets approved. But canceling is not bulletproof. If the contract cashes in your offer, then it'll just continue. So we have an incoming payment of Kate's Faucet tokens, and then finally that shows up in our purse. There we go. So now we've actually achieved the Faucet tokens. Next thing to show you is basically that's the end of the demo. So it is important to note that I didn't fast forward through the actual approval of the offer and stuff like that. So this is actually in real time what a user would see for a typical offer being made to their wallet. Yeah, let's move on. So next steps. Dealing with latency is our #1 concern. So what is very useful, well, we'll talk about this in a second. We want to be able to publish the API server to the internet so that other people can use it. And we also want to be prepared for future Agoric features that may make this all a little more easy to do. So with latency, the Dapp just works. Okay, so although I hit a race condition where I created an offer too early before the wallet UI or the Dapp Faucet UI was ready. Aside from that, the Dapp works, but it's slower than necessary. This is, as I said, it's still, the finality is between 2-second blocks on our Cosmos-based chain. But although that's faster than, say, waiting 15 minutes or half an hour for a block to become completed and verified, the dApp works, but it's still slower than it has to be. So an important thing to do with your dApp when you're getting ready to deploy for the testnet, and in fact, I'd recommend this even earlier, is you want to run your local sim chain with Agoric start delay equals 2 for a 2-second delay. That emulates the actual delays that your dApp will see on the chain. So we want to also make sure that your UI doesn't silently stall. We want it to give feedback for all of these processes. So there's currently a few hooks left in the fungible faucet UI, where certain events published by the wallet and by the chain are not advertised or associated with progress spinners. So filling out those different hooks and saying, okay, now we're creating an offer, but we have to wait until the offer is actually accepted by the wallet. That would be a good time to display progress in your UI. And round trips are the killjoy, basically. If you use await frequently, every time you do await in a linear flow in your contract or your deployment script, you're waiting for a whole round trip to the chain and back. So that await will say it's 2 seconds to go there and back for an await to be fired properly. So what you really want to do is decompose your async functions, break them up into smaller bits that are themselves individual async functions that have a direct flow and use await internally. But then we want to use promise.all to combine all these flows together so that the async functions can all run independently and concurrently. That will help also batch all these messages out to the chain rather than just waiting for an individual ID to be resolved, an individual value to be resolved, and all these things with await, with excessive awaits. Finally, we have promise pipelining. So this is a terrific invention. I don't know who to credit it to, but some of the Agoric founders were very instrumental in that. But the eProxy maker, the method caller that you can use, basically we say you can call E on an object and get back a promise for the method result. But if you call E on one of those promises that came back, you also get a promise for the method result. So you don't have to await every object that you get back in order to call E on them. You can just call E on the promise that you got back. So now if we want to publish the API server to the internet, don't use reset, whatever you do. So after you've actually deployed to the testnet with the Agoric start testnet, as we used before, you want to just keep that state and use it over and over again. So don't use the Agoric start reset testnet, just use the Agoric start testnet without the reset. So you want to install the Agoric SDK and the CLI on your server, just as the getting started dApps. But now you want to transfer your whole dApp directory, including the egg state directory. So transfer that to your server, and it will be able to pick up exactly where you left off when you had first deployed to the testnet. The next thing is more of a DevOps issue, is you want to provide an HTTPS or WebSocket reverse proxy in front of your dApp. So your dApp has a localhost 8000 API exposed, and the /API is a convention for the parts of the dApp that are publicly, could be publicly accessible. So you don't want to expose all of localhost 8000 to the public. You just want to expose the API subpath and anything below it. Also, you want to set the API URL in your UI directory before you publish it to the internet. That way, rather than using localhost 8000 directly, which won't work on your user's machine who runs your UI, this changing the API URL to your public HTTPS URL is basically what you want to do. So that way the UI can be used by anybody else who downloads your app, your dApp. But will reference the on-chain or the public instance of your API server. Some Agoric features that we can look forward to is, first of all, we want to use Cosm.js to replace the dependency on Golang. So Cosm.js is a great library that's currently being developed for the Stargate release of the Cosmos, which allows a JavaScript client to fully have a light client and to manage keys. So the only reason we had to compile that Golang dependency before is because it was the simplest way of getting an interface between a JavaScript program and just run a program to submit transactions or to receive transactions from the chain. So Cosmos.js will make this possible to do entirely in place. Another thing that's coming up is the rendezvous service. So right now it's a little bit convoluted to get an invitation from the API server into the wallet and then use it. You notice that it showed up in our invite purse, and then we had to create the offer with the invite and then use it again. So the rendezvous service will basically allow your Dapp UI to request the API server to connect directly to the wallet, the user's wallet. And this is not, again, this is not a privileged connection to the wallet. This is a Dapp connection only. So that Dapp will be able to submit offers on behalf of the Dapp API. And the API server can generate its invitation and send it directly to the user's wallet. Also, we want to provide basic components for a bunch of different UI frameworks to use remote OCAPs directly. Some of our sample dapps use a WebSocket API to talk to the Dapp backend, and also use the same WebSocket API to talk to the wallet. But those WebSocket APIs have custom messages depending on what kind of functionality you want to call. And there's a lot of glue code to make that work properly between a Dapp and your wallet or the Dapp API. So what we want to do is provide basic components like React components or Svelte or Vue or whatever you might have that can actually encapsulate the remote E method. So your UI would actually be able to use E within it to submit transactions to the wallet and to listen for notifications that you might want to respond to. Finally, these are our usual resources for the hackathon. The intro to hackathon documentation, and the actual Agoric SDK code where most of this is implemented. And finally, the contract examples that you expect to find. Thank you, everybody, and I hope this has lent a little bit of clarity as to how the whole testnet can work together.
Thank you, Michael. Much appreciated. And as a reminder to people participating in the hackathon, deploying to testnet is optional, so you get bonus points for it, but it isn't required to be able to submit a project. We would love to see a few of you do it just to see how your process works and get questions from you. But yeah, I would view it as bonus points. All right. Well, thanks again, Michael. I'm going to take you down, and we will close.